Hi, this is the weekly science update for the week of September 3rd. All right, so on Monday, we continue with the Save the Penguins unit. We continue with house temperatures and light. I'll go over that in a little bit. We also went over the temperature versus thermal energy sim from the previous week, the Schoology assignment. We went over the answer key. All right, so the house temperatures and light. Well, let's take a look at what we did with that. So let's go to the reference notebook. Let's go to page 11 of the reference notebook. I'm going to show you the storyboarding of what we did in that activity. So basically what we did is we had a cardboard house with a black roof, and we shined a couple lights at the cardboard roof, the black roof. And so we kind of went over what happens when visible light interacts with the black cloth, white cloth, and a red cloth. So we see that all the colors of visible light, they get absorbed by the black cloth, and so that explains why the black cloth gets very warm. And a white cloth, when visible light is shown on it, it gets slightly warm, and that's because all the colors of visible light gets reflected by that white cloth. And a red cloth, all the colors of visible light get absorbed except for red light, which gets reflected. And that's why you see it as red, because it gets reflected back into your eyeball. So the red cloth gets kind of warm. All right, so we also talked about how our light bulbs we're using also give off infrared light. It's not a visible light. It's not a light that can be seen by human eyeballs. So when infrared light hits a white cloth, it gets absorbed. And so that's why white cloth does get slightly warm. It doesn't stay all the way cool because of the absorption of the infrared light. And aluminum foil can reflect all colors of visible light and infrared light. So that's one interesting properties of aluminum foil, unlike white color. All right, so we also here's the diagram of the cardboard house with the black roof and the light being shined on it. And we have a thermometer position at A and a thermometer position at B. So A is closer to the roof than B. And it's measuring the temperature of the air inside. So what happens is when the light source hits the black roof, again, the black roof absorbs all the colors of visible light, and the temperature increases as a result. And that is a thermal energy transfer called radiation. So radiation is the transfer of thermal energy via electromagnetic waves, or basically light. And so what happens is the air molecules that are underneath that black roof, they're all moving around, and when they come into contact with the black roof, well, black roof has a higher temperature, the air molecules has a lower temperature, so the air molecules gain energy from the black roof, so they jiggle faster. And temperature measures the average motion of the molecules. So if it jiggles faster, that's an increase in temperature. And so it happens slowly over time. Again, the area that's closest to the black roof increases in temperature greater than the area further away from the black roof. So that's what we saw as a result. So that transfer of thermal energy is conduction. It's by touch. The molecules touch the roof, and the air molecules touch the other air molecules to transfer thermal energy. We then flip the house upside down so that, basically, as shown in the diagram here. And so what happens is that cooler air that was at B sinks, and the warmer air that's at A rises. So that's convection. So if we find the definition of convection, which you wrote down on page 7 of the reference notebook, convection is where fluids, which are gases or liquids, sink or rise because of the change in density. So that's what we saw in the house. We also wrote down the formal definition of radiation and conduction. So these are our finished heat transfer key terms for the unit. All right, let's go back to the calendar. So we just kind of went over the storyboarding of the concepts that we learned in the cardboard house. All right, then when we went over the Penguin Shelter Engineering Challenge, so let's take a look at that. All right, so basically the problem is the city of Rockland wants to display these Antarctic ice cube penguins during the summer, where the conditions are basically it's 100-degree temperature days all the time. So what they have to do is their task is to use knowledge of heat transfer and thermal energy to create a device that will prevent these penguins from being harmed by heat transfer from radiation, conduction, and convection. So that's the main idea. Okay, so then they had to do the initial individual shelter design. So let's take a look at that. All right, so this is to get their initial individual thoughts out there because that's important. Before they get into the groups to do the challenge, they need to kind of know what their thinking is already. So I gave them this paper, and they had to draw their ideal penguin shelter. And remember, the goal is to protect the Antarctic ice cube penguin from the extreme summer temperatures of Rockland. Your drawing needs to include the labels and descriptions of different parts. You need to explain the following: how will your shelter protect against conduction, convection, radiation? Which ones actually happen? How would they happen? Somewhere in your explanation, you need to list all 8 of our key terms at least once. So I went over that, and they started on Wednesday. I gave them some more time Thursday. So by next week, it should be all ready, and they're going to share it with the rest of their group mates. Now, I also did a video overview of what I said in class so that students that are absent, they can take a look at it in more detail than I just did now, including a picture of their setup of where the lights. We're going to simulate the summer Rockland days with this container filled with aluminum foil, light shining in there, so the air temperature is going to be 110 degrees in there, and the felt paper is going to be a temperature like 130, 140. So this is a diagram of the setup where they have to design a shelter that protects their ice cube penguin from that thermal energy surroundings. So I included that on the calendar right here. So I gave them some more time on Thursday to finish up their initial individual shelter design, and then we started materials testing. So this is page 12 of the reference notebook. So if we take a look at page 12 of the reference notebook, it's going to look like this. Although if you look at the reference notebook, it's going to look slightly different because I put it vertical instead of horizontal. But I also gave a link from here to here so they can easily see it. So we have, these are the materials that can be used for the project: white paper, black paper, pink paper, white cotton balls, aluminum foil, white felt, white foam, black foam, mylar, brown paper towels, bubble wrap, etc. So what they do is they test the material, they shine a light from the light bulb, and they have a thermometer underneath the materials, a little bit elevated from the countertop. And so they time it. They get their initial temperature at time 0, and then they see how the temperature changes every 30 seconds till finally 180 seconds gone by, so they calculate the total temperature change. And so based on that results, they're going to determine which materials they actually want to use for their device that they're building. All right, so that's basically the weekly agenda for this week. Hope you have a good 3-day weekend. Bye-bye.